America was.
Hello, hello, hello. Welcome. A bit late today, but I guess better than ever. All right. Let's get right on with it. We had yesterday a syncing problem. Let's see if we can fix that today. We don't have, like, I don't have plan to stream that long today anymore. But yeah, it would be at least nice to fix that so that we next week can focus on actually getting all the different levels down to the most subdivided we potentially want, and then we can run the mesh extraction again. Hello, Captain Chico. And hopefully all of that works out. So I am thinking maybe what we need is actually that. Where we actually do this. It's just an idea. And then we do this here. Because I think the compute barrier, it's pretty much the same. It's a VK command pipeline barrier. And pushed as a memory barrier. Isn't that the same what I do here? VK buffer memory barrier. I mean, it's still a VK command pipeline barrier, so it's pretty much the same. Right? Because I think between a memory barrier and a VK buffer memory barrier. No, you can be direct. But I know I'm bad at it. So that one we dispatch to read, that one we dispatch to write. Oh, nice. Congratulations. Congratulations. So will she move as well to Barcelona, or will you move back? Or not really plans yet in that regard? All right. So this, and then I probably, oh, the context. Oh yeah, the context is compute. And I want to get rid of this for now. Even though that should be not an issue, but let's see. We can still do the global barrier as well. With memory read or shader read? Maybe shader read. God damn it. And shader right, this one. But nice, happy for you that it turned out great. Render doc. Now you have to cook something for her. Isn't that bad? Oh, that looks maybe good. I don't know. Oh no. God damn it. Sad. I was almost getting excited here. We can see what happens if we do 4 levels, if that makes any difference. Maybe it's just that we don't see it. Updated all the way. Okay, I mean, that's not so bad. UN64T node. Okay, so maybe it actually works, it's just that I don't see the last level. Or she works in medicine, so her part is kinda easy to deal with, but we were talking about it. Oh, okay, cool. Nice. Austria of all places, maybe. Are you following me? No, just kidding. Resource inspector. wanted to see what my total node count is. $681. Okay, I mean that's not too bad. A free room in the mountains? Nah, not really. Okay, so maybe that is actually not needed. I have no idea. Maybe that is already enough with the compute barrier. We should make that nicer though. And then let's get down to level 5, right? Which is, well, actually we want to get down to level 6. So we are at 5, and 5 still subdivides, but we stop the subdivision at that point. Which means we basically stop writing into this create info here. And that would be basically if the depth mask is 8 to the power of -1, should be this. Okay. Yeah, that's fair. I can understand that. What's actually the performance of this? I mean, again, render dog, take it with a grain of salt. Doesn't look too bad. Render dog is slower, so if that already shows something like that, then this is very quick. And I mean, it is very quick because you barely notice it when we go to the scene view. Which, I mean, kind of makes sense because it's about 600 nodes. Okay, so that was a little bit... Oh, well, okay. Because we broke the shader again. Oh, yeah, because... it's EU constants. Well, actually, you could probably do 32768 with a great child offset, with that being like that. That I can totally relate to. If it wouldn't be for work, I would prefer that as well. Okay. So that worked. Let's see how many nodes that in total is when we go to the lowest level here. Because we still subdivide all the way down. Okay. I assume that then is quite a lot of nodes. Ah, no, that's not what I wanted. I wanted to see the total node count. Okay, 10,900. That's not too bad. I would want to know maybe how many are in the last one. Do I write that? Oh yeah, I might write that. in one of those. $8,100. I think that is probably the last one, right? If I would have to guess. Yeah. Okay. A bit of a problem maybe, but let's see. What's the node size at that? We can actually figure that out, right? Setting a breakpoint here. So the octree actually is constructed correctly. Okay, so it's 2000 something, so one of those nodes is then 1000, right? Oh, okay. Well, good to know, I guess. Yeah, I didn't think of that long time into the future yet. But yeah, eventually I have to. Alright, so that works. Now the question is, how do we queue the next lever? The next level would probably be best. Let's try something. So we do indirect dispatch buffer last, or like yeah, well, actually the indirect dispatch buffer not, we need the level node count buffer. Like next tree node, or next tree creation queue buffer. Let's do something very naive for now, which might not be the best. But when we, so if, well, we definitely swap, but if, or do we need to swap? Or we might, so this becomes current, this one becomes the next. So if our depth equals 5, which is the last lever, then we do this one, otherwise we do the other one. Why is that not? Okay. Let's not do it like, I guess it doesn't work like that, okay. If depth is 5. We can say push constants next lever not count buffer is that. And then we still do the same thing. Just that for now we do here, we can nest that loop, but we don't need to for now. So basically we do those multiple times. Here we always set the push constants next level node count buffer to whatever we had it here. Does that add up? I mean, actually we can do it like that probably. As long as we do it with depth 0 as a start, right? And then we swap always at the end. And if depth equals 0, then before doing that, we push this to the indirect dispatch buffer 0. Oh no, that actually doesn't work. Not really. So we still need to do that. I still think that is fine. That is probably fine as well at the end. And that is fine here. But at the end as well, if depth equals 5. I mean, we still swap. And push constants next level node count buffer is this one. Do we need to? Probably not actually in that case, because that will automatically happen. But we need to swap back here at the end. Oh, that's painful. Because I have no idea how to do that nicely. The idea is there, the execution not so much. So definitely the idea would be as well that this basically we do only once. My product manager is a wild lad. Why is that? Wait, the next level node count buffer? Wait, can I do that in the shader maybe? No, right? Because I still need to read out how many nodes there are. Huh? Oh, maybe not actually. So actually we can do that. So if then we can reset it here and we don't need to do anything. So if u constants, oh, but yeah, okay, no, we need a separate buffer though. Yeah, I will open it after the stream, it's fine. Just to be sure. Because I don't know where my Discord is currently. I will open it after the stream. Don't want to potentially leak something. Okay, so the idea would be that we go in here one time. I mean, we could always dispatch. Yeah, we can always. Actually, let's do that, yes. Let's bind the shader here. And then let's always dispatch the route like that. Or we set it like this up. And I do think this could be always 0, right? Doesn't really need to matter in this case. And then we dispatch. And then we do command buff while push constants. Current lever is lever node count buffer 0. Oh, that's the dispatch buffers, never mind. So that one is this one. And then this one will be 1 for the next lever. And then if we are 5, we have to swap in the next lever. The root size. And node extents we can do basically like that. But it's basically the same thing like that, where the depth local depth. Oh, that's the local depth, right? And the depth mask as well, local depth. But the node extends is the full depth. And then this is the root side like that. And this is the node extends half. Or? Yeah. Although that kinda falls apart, doesn't it? Doesn't that fall apart a little bit? In the sense of that it doesn't know where the node is for the parent? Maybe that was not so smart after all what I did. Because even though that would work, we still need to know the full position. Which we currently don't know. I mean, let's see what happens if we just... I mean, we probably already run out of queue space then. Let's revert a couple of things back. Because why not? I mean, maybe we do. I don't know. Let's see. Let's do that one from 1 to... Let's do one more level. Let's do 7. And then let's here switch that to 8 to the power of 6, which is this. Which I think we will now run out of space. Okay, maybe not. I mean, or we override. I mean, that could be the potential issue, right? Oh, no, it actually crashed. I mean, why did it crash? Because it didn't crash here, right? Hmm. We can always make the queue a little bit bigger. Oh, well. I mean, that is definitely a problem. Okay. That works. Doesn't look so bad. Let's see. Pipeline state. No, resource inspector, that's what I wanted. Wanted to see what's the total node count. $27,000. That's actually not exponential growth anymore. That's pretty good, I would say. Let's do a bit more sophisticated check, maybe. For the splitting. So we only split. Oh, we need some more information though then. So basically we need... Do we use that offset? I don't think we do, or? Oh, we do, but... Oh no, yeah, we do. I'm not sure. Let's add a vec3. Or do I need more? I mean, actually, do I want to add it here? Yeah, I think it makes it easier to add it here. Like 3 camera position. Because I don't think we need anything else. Per se, for now. We can do that and uint padding. This and a uint padding. And what we will do is basically push that as 0 for now. Because we don't really care. Then we take our children here. And basically here we can already say if our child extends are less than our load distance, then we just return as is. We don't need to calculate any of those. And we actually mark ourselves all of our children as leaves. And the load distance is something we will calculate for now. And that is basically our position minus the camera position. Length. So that gives us the distance between the octree center and the camera. And then if that is or let's actually do that. That's like 0.0 f float distance to camera. And then if our distance to camera is less than 100, load distance is 100. Wait, is the load distance maybe just... No, we want to actually, yeah, it's not like that. It looks like that, but it's not. If the distance to camera is less than 400, or this is actually not, sorry, that is 0.1. Because that's our meters, right? We go here to 50. And then if our distance to camera, let's do 250, is load distance 0.25. And if distance to camera is less than 1000, again, not sure what good values here are. It's a bit winging. But we're not really getting into the territory anyway. I mean, actually we are. Ish. No, actually, probably not. At that point yet. So maybe that's actually useless what I'm doing here. Uh, 2 meters, that's what it was. That's 1 kilometer. Yeah. Well, that's not the lot distance then, right? That's the lot child size actually. Because that would be the lot distance here. Not that matters right now, because we don't really go down that road. Let's actually go way bigger than on the distance. But can I just fit it everything in one tree? Maybe I just overcomplicated it. Let's do 9 levels here. So 9 levels would be... What's the size then? It's 64,000 divided by 1 shifted by 9, which is 512, right? Is that right? 1 shifted by 9. Yeah. So that was 125, which is still huge. So probably, yeah, we need to get down quite a lot to get a resolution that we would want. Which I'm not sure if we can achieve with the current setup. Because the nesting was a good idea, but I think in practice it actually doesn't turn out that great. So how many do I need to get down to 1000, right? 64,000 divided by, well, 64 basically, right? Which is just 8 times 2, alright? Wait, what? Oh no, it's 1. Okay, so that's times 7. Is it shifted by 7 is 60? Ah, it's 1 too much, damn it. 1 shifted by 6 would be 1024. Yeah, I think I probably want to keep it like that. Well, we built this to level 6 basically. But then how do I build the outer positions? Because basically I need to the thing is we have a little bit of buffer right now, right? Because the voxel offset I'm not intending to use probably. So we would have 24 bits to spare. But I'm not sure if I want to keep that in mind because we might want to use the voxel offset potentially. So maybe I don't want to just snag that and do something with it. So, okay, how could I go about this? Maybe the queue needs to be full buffer indices then? Maybe that was the oversight. Maybe it can't be just U32s. Because currently that is a U32 because it... Oh yeah, it has the offset in it plus the Morton. I mean, another way would be we write into a separate buffer the requests for new trees. So basically... I mean, that would probably work. Or can I make it somehow work within the constraints of this? I mean, I might be able to do it, right? If I change this to a U in 64T, we unfortunately double our size. But do I need that? Probably not, actually. I could keep this local, right? I just need an offset somehow. But how would I do that? Could I maybe do it? I mean, that's all a bit crazy anyways, the layer here. Maybe doing that on the GPU is not the smartest. Hmm. I mean, I might as well just rewrite it and do a full word encompassing octree. Would that fit? So that would blow this up to a UN64. Well, that would actually result in this being a struct. Create request. Where it's a UN64T Morton. And a U in basically a U in probably of offset. And this would be this. And then this would all stay the same. That would all... This would be a U in 64T then. Which we can probably do like that. And then the padding is gone, which is not so bad. I think that all stays the same. Pretty much. This one becomes 63. But we need to change this anyways, because this Octree create info now is not... It's like a create request, right? So basically we need to do that. Act create info, where this is the Morton index. And that becomes a UN64T. And that becomes this. Octree flat index becomes just that. We need to add the 64-bit version here. Depth mask, fine. All of that. That is a UN64T. And then we don't need to pack anything. We just need to say add that. We do a new one. Where the first thing is the shifted Morton plus I, and the Octree children offset plus the valid index. And then we pack our Octree, and that's about it. Just need to add the Morton version for a 64 uint. Yeah, that basically really just returns a uint, that's fine. And we need to go to our Morton here. And it's this, but in what order? 9 to... Okay, so it's the reverse order, right? Ah yeah, because it's the decode. So we go from the back. It's this. This. And then another one by 32. Does that make sense? No, right? Hello, Capuche man. Okay, so this has to be a U in 64T probably. We shift it and then we can cast it to a U at the end. Probably. That should, in theory, should it still work? I mean, it basically should still work. U64 plus size of U32. What to create. We already fixed it, I think, but yeah, glad to hear. Okay, yeah. Yeah, it seems to work. It's just that RenderDoc doesn't show it correctly. Hexadecimal literal too big. Okay. Or can I cast this? Can I do a U in 64T like that? Or do you not like that? Probably you don't, right? Hexadecimal too big in 23? Yeah. Okay. Morton code 3D. Can I copy that value? Of course not. That would be too nice. So one write access at a time, not write command. Okay. Oh shit. I wanted to have it as hex. And then I copy this value in here. Oh wait, that is actually... I mean, I hope that is correct. Otherwise it will be pain. Okay, so it ends in 401. It ends in 401. Okay, so that is okay. Now we have 209151. Yeah. Then we have 872871. Looks fine. 872671. Yeah, 115551. Do we have the last one as well? No. Hello. Hello, hello. Alright, let's see. So that should hopefully work. Maybe there is an extension that would support this. Does it not like that as well? Oh my god, what? There's no literal support for that. I mean, that would be unfortunate. Where is it? It's this one. Oh, okay, so UL. So we can do literals? What can I do? This, please. Will you allow me that? Dear shader compiler. Okay, that looks better. 31. That's a different error. Oh yeah, that's this, of course. Do we want this buffer to be 8 bytes aligned? I don't think so, right? I mean, maybe. But we probably have to have a padding here then. But I'm not sure. Let's see what happens. Alright, 137. Return non-void function must return a value. Don't tell me what to do. 100 what? 137. Oh. You are right. As always. Compiler. Alright, a couple more shader errors. 251. Okay. Is it not? Did I not call it that? Oh no, I called it uppercase probably, right? Yeah, Morton. Of course I did. Of course I did. So we do this, and that is offset, that's fine. Of course we still don't have it. 260. Cannot. Okay. 260. Ah, this one, right? Yeah, that makes sense. Not that we need that right now, but it's fine. Create chart offset. Oh yeah, okay, I see. That is a bit of a problem. That will definitely be a problem. God damn it. That is definitely... Guess I have to go a little bit back to the drawing board again. I mean, worst case, what would it turn out to be if... If I have a 1024 tree. If I divide that by... one shifted by... I mean, 10 is probably 1 meter, right? Because that's 1, yeah. I will get some water because I ran out, but I have to think about that a little bit. But we still have a little bit more to go today. So let's see, maybe I can come up with something. Because I thought that the other trees are kind of easy to do then, but I ran into one problem that I don't know how to fix. And yeah. Need to figure that out. Yep, be right back. Alright. Let's see how many bits. I had a quick idea, but I don't know if that works out. Although that would be kind of butchering the offset. It would be so nice if I can do, like, if I could manipulate the push constant somehow. But that's not really a thing. And then again, I as well don't know how many subnodes I need to create, right? It's all not so straightforward. And this one... definitely a problem as well. Let's, I will save that away. And I will mostly revert everything I did. Because I just don't see that happening in terms of memory efficiency. Is that now mostly reverted? That one is back to normal. Yeah, okay. So let's go back to square one and let's think about it. We could do, for example, if we have one I mean, currently that goes down to 6, right? In theory, in this uint, we have 14, no 15 in the like values available, divided by 3 is 5. Okay, so we don't have any more leeway here. In this 5 is really the lowest we can go with this packed offset here. If I would in 24, how much can I store there? 8 levels. It's not good enough. Not good enough. How about I actually deal with that? Maybe I deal with it somehow on the CPU. If I do and split that, right? The 60. Oh, well, that is a bit of a problem though. Because that's cubic, right? So 64. 64 times 64. I mean, that's not too bad. That's manageable. We could as well. Hold on, maybe we do it. Maybe we do it a little bit different. Maybe we do it like this. And then we read back. That will take a frame or two, right? We could do that actually. Hold on, maybe that is a good idea. So on the last level, which would be this one, we don't write anything anymore in here. And we don't... Well, that basically means that already, right? Because we don't allocate the children anymore. And while that is an offset, it will point outside of the buffer range, basically. So we could do a read path. Do I need to somehow transfer it? We could cache it maybe, but I'm not sure if that's the best way. Can I do like the reverse of a staging buffer basically? Probably, right? So the idea would be we sync back the generated tree, and then I see which nodes requested new children by the valid mask or by the child mask, and then I can queue those for subdivision with a new tree. That would be the idea. And I think that would make it quite Nice, because then it's easily controllable as well in terms of how many we launch from the CPU. So yeah, probably let's do that. And I think I have like a couple more minutes to stream, so let's... I still don't know how to do the readback though, to be honest. I've never done a readback from a device local buffer, and I'm not sure if I want to mark it as not device local. That's the biggest thing I'm not sure about. Does Tracy still work? Am I still running Tracy here? Oh, that looks like I'm doing something. Oh well, of course it failed. I did something with my shader wrong. Probably this one, yeah. Is it running now? Yeah. And is it now? Okay, no, it doesn't do anything here tracking wise. Unless those are the buffers, but that would be insanely fast if that's it. Can I somehow decide what it's shown in Tracy? Shouldn't it be... maybe with a debug label? How was it again? How did that work? God damn it. Add Tracy marker. Or the debug name of the pipeline, and I don't have a... oh, I don't have one, yeah. Volume power chunk tree update. Really? Oh no, here, word chunk tree update, okay. I mean, that's pretty negligible. It's 1, 2, 3, 4, 5, 6. Oh, it's weird why we have so many, but... oh, that's not the word. That ends here. 1, 2, 3, 4, 5, 6, 7. Did we do really 7? Oh, we do actually. Because 0 and then 6 of those, which is this not correct. Because that blows out our buffer. But yeah, that's pretty negligible, as I said. So probably I move this to some sort of temporary, like a... yeah, an area where we can have this reusable so that we can call it for the sub trees to generate. And then it's really just that we give here in the push constants next to the camera position another position which is the offset of the root. It's getting quite big, but I think we still have space here, right? Yeah, more than enough. I think we have space until 128. But yeah, I will... In hindsight, I'm already quite hungry, so I'll probably call it a day. It's a bit of a short stream, sorry for that. I was late, I was a bit lazy today. Not gonna lie. But the plan is... What day is tomorrow? 4th. Well, let me quickly check my phone. I think I have nothing planned. Yeah, I don't have anything planned, so I will be back tomorrow. And then let's try to stream a full week again. Without me trying to be lazy. So that we can get some stuff done here. Thank you very much though for joining, even though it was... Well, we got the terrain chunk, like the first terrain oak tree done, right? So, I mean, the first level of it. So if we go here to our beautiful resource inspector, we have here a bunch of nodes, which you really can't read because they are just UN64 encoded. But we have all of those nodes here. I'm not sure why there are zeros here. That's a bit... That's a bit weird, but let's not deal with that yet. Oh, that might be because we are running it multiple frames, maybe. Or maybe that's the children of nodes that no longer subdivide. That might be it. That might be the branches that are basically created, but then they don't do any subdivision. But at that point, why is it even there? That's a thing we should investigate. Because I thought I only create stuff. I thought I only create a node when I need it. Well, that's definitely something to check out, because that shouldn't be the case that we have holes in the tree. Like zeros like that, I think. I wouldn't know why that would... I mean, we always pack it in. Which, I mean, makes sense. Leaf mask, child mask. I don't think we should have something here if we don't. Is there one reason why we would be ending up here? So that's actually something I want to still figure out, maybe logically. So we come here from a parent, get our center position, and we go in here. Which then comes in here, checks our children, which I hope are unique. It looks like they are unique. 0, 1, 2, 3, 4, 5, 6, 7. Okay. And then, I mean, maybe the Morton is wrong. Okay, I should probably find that out. Maybe we end up in the wrong child index, get the wrong position from that, and then this basically results in it being wrong. We can add some shaded debug info for that. I mean, we might actually just do that. Where was that? Was it in generate? Debug print, yeah. And then print, yes. I think actually we should probably make a macro for that. In like debug print. I don't know. Maybe not. I don't know how to do it in GLSL yet. So let's not do it. But let's... God damn it, what did I do? Oh, here. Oops. Request subdivision child 0. And then can we do the position here? Does that support? Does it support some adding of properties? Oh, it's a percent. Oh, okay. Basically percent F, percent F, percent F. And then this is child center X, child center 0 Y, child center 0 Z. One, 1, 1. Two, 2, 2. Let's do that as a last thing today. Let's debug that part. If we're actually subdividing the right one. 4. And I will send you off for the rest of your weekend soon. And I hope you will have a great start into the week as well. So, then here 6. That is a bit painful. I think I want to look at that potentially as well in the future if we can wrap this somehow. But for that I need to be a bit proficient with what I can do with GLSL macros and stuff like that potentially. I don't know. If it even supports something like that, I don't know. So that is this, and then I want to have here handling node. And let's do Morton index at depth, I don't know. %u maybe? Which is u and Morton index at depth. Or do we maybe... Let's do it like that and let's get the coordinate out. And then we do node center position. X, Y, Z. Alright, so that's that, and then we only do 2 levels for now to make it simpler. And let's actually only do it once maybe. Do not spam. And then we can go to Visual Studio, copy out the log. So that it's a little bit easier to read maybe. Well, I say easier to read. Perfect. So we're requesting subdivision of those. Okay. A bit sus. Hold on, does that make sense what I do here? I mean, those positions kinda make sense, right? But then shouldn't this and this align? That doesn't look so much. That doesn't look correct. Let's put it that way. Coordinate 0, 0, 0, 5. That makes sense. child center makes perfect sense as well, but this one then doesn't make a lot of sense. Node extends minus root half extends, so it's probably the node extends that's wrong. Because the coordinate looks fine. It's just that it's one unit too small. Because that makes... Does it make sense? Yeah, it does make sense, because we're 64 big, right? So those are the centers of the 8 sub-quadrants. But then this should be the same, so where does that come from? We do the node extends is the root size and 1 shifted by the depth. Maybe this needs to be 1 shifted by the depth minus 1 as well. Okay, now that is 32,000. Which is the node extends, that's fine. That is 7, which makes sense as well. Because that was working, but it seems like it's a little bit off. But the root half extends, they are fine, right? Where are my root? Well. Let's maybe look at the push constants here. Wait, what? Oh no, yeah, that makes sense. But then here, shouldn't that be... Can debug that here actually. Then that times the node extents is of course 16,000. Okay. That's fascinating, to say the least. Did I maybe port that wrong? Well. I will look at that tomorrow. If it looks a bit funky, that shouldn't be the case. That should be... Oh, because we are doing... Wait. Because the depth mask... Is it the depth mask? No. Yeah, no idea. I will look at it tomorrow. Yeah. Thank you very much for joining. We got, as I said, the Octree almost running. A couple of smaller mistakes here and there that we can fix, and then tomorrow we will fix those, as well as add the readback so that we can queue the next level subdivision. And when we have that readback, we basically have everything I think we need to go all the way down to level 4, which is the smallest Octree we want to build, potentially. So yeah, thank you very much for joining, and I hope to see some of you tomorrow. We will start tomorrow at 7:30 probably, yeah, like the usual schedule during the week. Let's see, can we raid someone maybe? Because it's always nice to do that. Yeah, let's go to Zed. He does some Go plus plus. Well, it seems some Go. I always wanted to see some Go, so let's go there. But yeah, thank you. Have a great rest of your evening, and hopefully see some of you tomorrow. Bye bye.